Welcome to the Explainer. Today, we're going to watch an idea, well, evolve. We're going to see how a system can go from being completely stuck with rigid, unchanging rules to becoming a living, breathing, logical engine that actually learns from its own mistakes. Okay, so to really understand this journey, we have to start with the two basic ways a system can think. On one hand, you have deduction. That's your classic top-down thinking. You start with a big general rule, like all swans are white, and you apply it to a specific case. Then, on the other hand, there's induction, which is the exact opposite. It's bottom-up. You look at a whole bunch of specific things, you see one white swan, then another, then 100 more, and you try to create a general rule from those observations. And right away, this sets up a classic conflict, doesn't it? Rigid rules versus a messy, ever-changing reality. We're going to see this exact battle play out as we look at a predictive framework that began by putting all of its faith in pure top-down logic. So, let's meet our first version. We'll call it the rigid rulebook. And, as you can guess, this is where pure logic is about to run smack into a wall. You see, this first version, V6.0, acted like a really stubborn rulebook. It was built on this idea called logical positivism, which is just a fancy way of saying it looked at old data, created what it thought were these unbreakable laws, and then just applied them to everything, completely ignoring any new evidence that came along. And here is that exact problem in action. The system is basically screaming, my old rule says the chance is 70%, even though the evidence right in front of its face shows that things have totally changed. I mean, the real rate is only 10%. It's a perfect case of the map no longer matching the territory. Let's look at a real-world example from April 16th. For a particular cycle, C10, the system looked back at its historical data, and based on its fixed, unchangeable rules, it confidently predicted a 60% chance of a clean hit. It was absolutely certain, because, well, its rulebook said so. And the punchline? It was completely, utterly wrong. Reality had moved on, but the rulebook was stuck in the past. And this one failure? This is the moment that forces the entire system to evolve. That failure led directly to version 6.1, learning to adapt. Now, for the very first time, the system is actually starting to watch what's happening right now and adjust its thinking on the fly. So, version 6.1 is a whole lot smarter. It runs on what's called a Bayesian approach. Now, all that really means is that it starts treating its beliefs as probabilities, not as dead certainties. It uses induction, that bottom-up thinking, to ask, hey, has the game changed? Are we in a different environment now? It tries to figure out the current regime and then tweaks its predictions based on that. And you can see the improvement right here on that same C10 prediction. By actually observing the new reality, V6.1 made a much more cautious and way more accurate prediction of just 12%. It adapted where the old system just completely broke. But this was still kind of a temporary fix. The deduction part of the system and the induction part were still totally separate. Think of it like this. The system wasn't truly learning a new way to think. It was just smart enough to pick a different playbook off the shelf. Its core beliefs weren't actually changing. And that brings us to the final evolution, version 6.2, the closed loop. This is where the system finally, truly learns from experience. This quote right here is the absolute key to the final version. It's so simple but so powerful. What the system learns today becomes its starting point for tomorrow. It's not just adapting anymore, it's constantly updating its fundamental understanding of the world. This creates this incredible self-correcting cycle. Step 1, you make a prediction based on what you believe right now. Step 2, you observe what actually happens in reality. Step 3, you update your belief based on that new evidence. And step 4, the most important part, you repeat the whole process, but you use that updated belief as your new starting point. Every single cycle makes the system just a little bit smarter. So, version 6.2, this is the hero of our story. It doesn't just follow rules or switch between playbooks. It combines deduction and induction into one single unified engine that updates its entire worldview with every new piece of data. Its map of reality is now alive, and it's constantly self-correcting. Okay, looking at our C10 example one last time, you can see how it all clicks into place. V6.2 starts with that original 60% belief, but then it updates it because of the recent misses, knocking its confidence down to 25%. Then, it combines this new, more humble belief with its high confidence in the current environment to produce the most nuanced and, it turns out, the most accurate prediction of them all, 21%.
So what's the big takeaway from all of this? This journey from 6.0 to 6.2 isn't just about a technical upgrade. What we've really been watching is a profound philosophical shift in how a system can know anything at all.
We've basically gone on a philosophical journey in fast forward. We started with V6.0's rigid, law-based view of the world. Then we moved to V6.1, where beliefs became probabilities. And we ended with V6.2, a truly dynamic model that finally understands that its map of reality is not the territory, and it must always be ready to self-correct. At the end of the day, the crucial point is this. You absolutely need both. You need that top-down structure that deduction gives you, and you need the bottom-up substance that induction pulls from reality. But the real magic, the learning, that only happens when you build a system that lets them continuously inform and correct each other. And this leaves us with a final question, because this whole journey isn't just about some abstract system. It's a metaphor for how we all think. So ask yourself, where in your own life are you still running on rigid V6.0 rules? And what could you understand differently if you started using a more dynamic, self-correcting loop?